ask you this. The vision or the image that I got learning about fat was that if I eat this egg or this piece of bacon, bacon may be easier because it's longer, that it will go into me and lodge right into my heart artery because it's fat.
Yeah, and it's tempting to say that because we know the composition of plaques in the blood vessels, it is composed of fats and cholesterol.
Right.
But that's not the end of the story. It's not just that we eat it and then it gets deposited in our blood vessel wall. What is so essential is to understand that dropping off fats and cholesterol in the blood vessels is a normal thing that has to happen. As I said earlier, all cells of the body need cholesterol. Cholesterol is essential to the health of a cell. And so the fact that you could have an LDL molecule depositing cholesterol in the blood vessels, it's good because the cells that create the blood vessel, they need cholesterol just to maintain its function. So the dropping off of cholesterol in and of itself is not bad. That is not an inherently dangerous event. It has to happen. The problem comes when the cholesterol gets oxidized. And that is so often overlooked. And I would want anyone to appreciate the relevance of this. We can't just assume that the cholesterol, it's been dropped off, now it's immediately causing a plaque. Nope. That's one thing. The next event is essential. And again, as I said, it must get oxidized. And so for a fat, an individual fat, a small fat molecule, or a cholesterol molecule, to promote a plaque developing in the blood vessel, it must get oxidized through oxidative stress. And then we have the beginning of the plaque.
Is inflammation another way of saying oxidative stress?
Well, inflammation is the next step. I wasn't going to do it, but you took me there. So once we've oxidized the cholesterol, we have a particular type of cell called a macrophage that's everywhere in our body, including our blood vessels, in the walls of our blood vessels, and they're supposed to be there. It's good that they're there. But it senses this oxidized cholesterol or the oxidized fat, and it senses that this is dangerous. If the body allows this oxidized cholesterol just to bump around into things, it can oxidize our DNA and cause mutations in the chromosome. It can oxidize proteins and affect the way enzymes are working in a cell. In short, it can damage a cell. So the macrophage senses this oxidized cholesterol or fat, and it consumes it. And as it consumes too many, the macrophage becomes loaded with these oxidized lipids, including oxidized cholesterol. That becomes a foam, what we call a foam cell, because when we look at it under a microscope, it looks like it's really foamy. But it actually is just loaded with these little bubbles of fat, not bubbles of air.
It's an obese macrophage.
Yeah, exactly. Yeah, it's a fat macrophage. And it is a very inflammatory macrophage. It begins pumping out all of these inflammatory proteins that can also be measured in the blood, like C-reactive protein. And in fact, many lipidologists and cardiologists think that because LDL is such a terrible predictor, that maybe we should look at something of a marker of inflammation like C-reactive protein. But it's kind of part of this same